Hey dear students, welcome back again. Today in this video we will learn about real number of class 10 mathematics chapter 1, that is real number. In this video we will learn about the introductions of this chapter 1 real number. Then we will learn about the terms which are coming frequently. Means the positive integer word is coming frequently in this video, so we will learn about positive integer. Next term come in this chapter is irrational number. It is very important to learn about irrational number, how it is defined and what are the uses in the mathematics. After that we'll learn about rational number, and then what is lemma. The important term in this chapter is lemma. So we'll learn about lemma, a proven statement, how it is used to make another statement being proven, and after that we'll learn about algorithm. At the last we'll solve example 1 of this chapter. These are the basic, you should know everything about real number, so I will try to make it very clear the chapter 1. Let's start the video with the introduction of this chapter. So basically this chapter is in Euclid's method. One is lemma, another is algorithm, and how it helps to taking out the HCF of two integers. So we learn about the taking out HCF. In the introduction we can also say it is the divisibility of two integers. Let us take the two positive integers a and b. The two positive integers, that is a and b, which gives remainder r. Here in this video it is satisfied that a is equal to bq plus r. Here where we can say a is dividend, b is divisor, q is quotient, and I is remainder. We will learn elaborately in the next of this video, and where we will also learn about next term is positive integers, where a and b two are positive integers. We can again find the irrational number, that are root 3, root 4, root 5. These are irrational number. How, what is the definition of it? And after that we'll learn rational number. So let's start with the positive integer. So what is positive integer? The definition of positive integers are the numbers without fractional part that are greater than 0. Means any number that cannot be in the form of fraction, means cannot be in the form of p by q. It is not in the form of p by q, and it is greater than 0. And next they have said these numbers lie on the right side of 0 on the number line. So if we will draw the number line, that is 0 in the middle, and then 1, 2, 3, and so on. And likewise in the left side there will be -1 and -2, -3. So in the second statement they have said these numbers lie on the right side of 0. Right side of the 0 this number comes, so these are the number we can say are positive integers. So friend, hope positive integers is clear to everybody. So positive integers is very much important. So these are the numbers that are not in the form of fractions. This is to be monitored. The fractions mean these are the whole number 1, 2, 3, 4, and so on. The numbers are not in fractions. These are complete number, or we can say these are the numbers. So let us move forward and we'll learn about now irrational number. Irrational number is very much important in this chapter, and not in this chapter, in also in the mathematics section. So irrational number. Now what is the definition of irrational number? So let us learn. An irrational number is a type of real number which cannot be represented as simple fractions. So here it is said it is cannot be a simple fraction. P by q cannot be a simple. It will always be in complicated. And next it is said it cannot be expressed in the term of ratio. So it will also not be in the form of ratio. So next they have said if n is irrational, then n is not equal to p by q. So here n is irrational number that is not equal to p divided by q, where p and q are integers, or q is not equal to 0. Q cannot be equal to 0. So we can say this is irrational number, means the numbers which were having fractions, but the fraction will not be simple. So let us understand by taking an example of root 2. So we'll take root 2 and the value of root 2 is 1.414213 and it goes on. So the values of root 2 is in the form of decimal, means in the form of fractions. The fraction is very complicated and the numbers which are coming after the decimal, means after the point, are not in the form of any pattern. They are coming in a haphazard manner and the numbers are not stopping. They are not terminating. First we can say the numbers are not terminating. Terminating means it's not stopping. Terminating. So it will goes on and on. First point is to not terminating and the next is the pattern is not in the recurring form. So we cannot say it is a recurring. So we'll hear first is not terminating, next is not recurring. Recurring. So friend, here after decimals we cannot find any pattern. It is not terminating and not recurring. So irrational number basically are the numbers, the decimal which are not terminating and not recurring, we can say as a irrational numbers. Means it's a complicated in fractions, not terminating, not recurring. So friend, likewise the value of root 3 is 1.73205 and it goes on. Here also it's not terminating, it's not stopping, it goes on and the pattern is not similar, so it's not recurring also. So we can say this is a irrational number. So friend, likewise the value of root 5, root 11, root 21 are the prime numbers and its value will be also in the form of not terminating, not recurring. So under root of these numbers are irrationals. Likewise the value of pi of the irrational number is clear to you. Now next is rational number, and the definition of it is a rational number is a number that is in the form of p divided by q, where p and q are integers and q is not equal to 0. So here we can say the rational numbers are in the form of p divided by q, where q is not equal to 0. So it can be any fractions. So we can take 1 by 2, 3 by 4, 7 by 8 and minus 1 by 3, and these numbers we can say are rational numbers. So here they have not mentioned about the negative integers, so we can take minus also. Now after that the most important thing comes, that is lemma. We learn about what is lemma. Now let us understand lemma in this picture. Lemma is a proven statement. First of all, it's a statement. One thing is clear, lemma is a statement and it's used for proving another statement. Means it's helped to prove another statement to come true. It is a one type of statement, the statement which basically proving another statements to be true. Let us take an example of number 2. So here number 2, if we can say number 2 is divisible by even number. Number 2 is divisible by even numbers. Even numbers. So this is one type of statement that 2 is divisible by even numbers. So here in the next part of it says, means we can take a 4 number. Fourth number is also divisible by completely by 2, that is equal to 2. So here we can say, so here by this statement 1, this is our statement 1. By this statement even numbers are divisible by 2. So we can say 4, 6, 8 and so on, the even numbers will be completely divisible by 2. So basic of this lemma is it's a statement. That statement helps to prove another statements. So I hope the lemma is clear. Now after that lemma, the most important is an algorithm? The definition of it is an algorithm is a series of well-defined steps, means there will be some steps. First of all, it is clear that it will have some step 1, 2, 3, 4, and it may be so on, and that are well defined, which gives us a procedure for solving a type of problem. So these are the some sets of steps. By these steps, we will get a conclusion up to a problem. We will solve a problem. So here steps are 1, 2, 3, and so on. And in the statement 1, there will be some sort of procedure in the statement 1 that will be predefined. Likewise, statement 2 will have also some sets of procedure, method, or values. And again in the step 3 and so on, and the collection of it, the collection of these steps which leads to a solution of a problem is called an algorithm. We learn this algorithm by solving some of the problems in this chapter. Now let us move. So next is theorem 1.1, very important of this chapter, that is Euclid's division lemma, and it gives the given positive integers a and b. There are two positive integers, that is a and b. One thing is clear, the integers are positive. There exist unique integers q and r. There will be two more integers, that are q and r, will satisfy a is equal to b multiplied by q plus r, where r is, where the value of r will be greater than equal to 0 and less than of b. We will understand it by divisions two values. Now let us take two values, 2 and 9. So here we'll divide 2 and 9. Here we'll divide 2 and 9, and we'll understand the theorem 1.1, that is Euclid's division lemma. So now 2 divided by 9, it goes 4 times. 2 4 ja 8. Now here we'll subtract and we'll find 1 as remainder. So I can say this is a basic of divisions. Everybody would have knowing this. Now here if we'll name these terms, the 4 is quotient, and 1 we can say as a remainder. Here 9 is dividend, and then 2 we are divided by 2, so it is a divisor. So here we can write 9 as in the form of it, means 9 is equal to 2, we can say the divisor, multiplied by quotient 4 plus remainder 1. So here 9 is our a. We can write 9 as a. Dividend is equal to divisor b. The divisor is b multiplied by quotient q4 plus remainder r. Here r. So here we can write a is our dividend. Next term is b. B is divisor. And the next term is q. Q is our quotient. And r is remainder. So friend, here everything is clear to you. The basic of this theorem is to take the values in the form of divisions. Then we can write in the form of lemma. Euclid's lemma division. So basic of this Euclid's division lemma is to find the HCF of two integers. Here 2 and 9, we can take out the HCF by this lemma. And what are the steps we learn? So here to find out the HCF, what are the steps? So step 1 here is the Euclid's division lemma to C and D. So here two integers, that are C and next is D. We find whole numbers q and r such that c is equal to d multiplied by q plus r, where r is greater than equal to 0 and less than d. So here we can say c will be greater than d. We'll write c in the form of D, that is divisor multiplied by quotient plus remainder. And the next step comes, if the value of R is 0 means remainder is 0, then D, that is divisor, is the HCF of C and D. So here they have said if R is 0, then divisor of the last will be the HCF. Divisor of last will be the HCF. And next says if R is not equal to 0, if we have R remaining will be something that is not equal to 0, then apply the division lemma to D and R. Then we have to divide R and D such that we'll write in the form of this. And now the next step, step 3, continue the process till the remainder is 0. So after that we'll find something, and at the last we'll find 0, remainder is 0. Then the value of divisor at this stage will be the HCF. Then the last divisor, will be the HCF. So let us understand by taking, now the first step will be to compare 12 and 16. Here 16 is greater than 12, so we'll write 16 is in the form of, that will be the our divisor. 12 multiplied by, we'll find it here, we'll divide 12 and 16, it goes one time. Here we'll write 12, now we'll subtract it, it will come 4. So here we have got quotient as 1, and remainder as 4. 4 is our remainder. So here we will write, so here we can say 12 as divisor. So we have written D multiplied by Q plus R. Here quotient is 1 plus remainder is R. So here the remainder is not equal to 0. So we'll have to process the second step. Here the second step, we'll have to take lemma D and R. So we'll have to write 12 is equal to, now divisor will our remainder is 4. So we'll have again the divisions 4 and 12 this time. 4 3 times is 12. Now remainder will subtract, it will be 0. So here we'll write 3 and remainder is 0. And here this is the divisor, this is the final divisor, we have got remainder as 0. So this is our HCF, so HCF will be two integers, 12 and 14 will be 4. So at the last friend, we can say these are the steps to take out the HCF of two positive integers in the form of Euclid's division lemma. Hope this thing is clear. So friend, do not forget to subscribe the channel and like the video. Now next move to the last, and we'll solve one problem of it. Now we'll solve the example 1. Use Euclid's algorithm to find HCF of two integers. One is 4052 and next is 12576. First of all, we will comparison the two integers, that are 4052 and next is 12576. So here we can say 12576 is greater than that of 4052. So for making it the form of Euclid's algorithm, we will write 12576 is equal to, this is our dividend and this is divisor. So 4052 is divisor, we'll multiply it by some value, we'll calculate it how it comes, we'll write here. Now we'll divide 4052 by 12576. So it goes 3 times. 3 times we will take 2 3s are 6, 5 3s are 15, remaining 1, 0 3 0 and 1, and 4 3s are 12. So now we'll subtract the values. It will be 6 minus 6 0, 7 minus 5 is 2, 5 minus 1 4, 2 minus 2 0, 1 minus 2 0. Now 420 is our remainder and the quotient is 3. So we'll multiply by 3 here, plus the divisor is 420. So this is the form of Euclid's algorithm. Now for the next step, this will be our step 1. This will be step 1. Here the remainder is not equal to 0. So we'll have to follow the step 2 and we will continue this process. Here the dividend will be 4052 and now the divisor will be 420 and the quotient we will find here. We'll divide. Now here we will divide 4052 by 420. So the quotient will be 9 times. It is nearby 10 times. So we'll take 9. 900, 2 9s are 18, remaining 1. 9 4s are 16 and 1. 9 4s are 36 and 1 37. Now after subtracting we'll get 2 minus 0 2. Now here we'll take 1. 15 minus 8 will be 7 and here it will be 9. 9 minus 7 2. 3 we have taken 1. This will be 3 minus 3 0. So here remainder is 272 and quotient is 9. So we'll multiply by 9 plus will remainder 272. So here in the next step we'll take step 3. Step 3 we'll change the color. Now step 3 the dividend will be 420 and our divisor will be 272. Now we'll take it here. Here it will be 272. We'll divide it by 420. It is 1 time 272. 10 minus 2 8. Here 1. 11 minus 7 4. And 3 minus 2 will be 1. So here quotient is 1. We will multiply by 1 plus we have again the remainder 148. So we'll have to follow step 4 also. In the step 4 we have to divide 272 by 148 and it will be, now here we will divide 148 and 272. It is 1 time 148. Here it will be 12. 12 minus 8 4. So here will be 6. 6 minus 4 2. 1 minus 1 124. So the quotient is 1 plus remainder is 124. This is our step 4. This is our step 4. And now step 5. We'll write step 5 here. Step 5 again. Here the dividend will be 148 is equal to the divisor is 124. The remainder will be divisor. So the quotient will be, we'll find here 124 dividing 148. It is again 1 time. So 124 subtracting 8 minus 4 4. 4 minus 2 2. Now here quotient is 1. So we'll multiply it by 1 plus remainder again 24. So we'll have to take one more step. Step 6. Now we'll have dividend as 124 is equal to, we have the divisor 24. Now multiplying 24 and 124. 25 5 ja 125. So 124 5 times. 4 5s are 20. 0 remaining 2. 2 5s are 10 and 2 12. Now after subtracting 4 will be remainder. So here the quotient is 5. So we'll multiply by 5 plus remainder is 4. So here remainder is 4. Our step 7 will be, now in the next step 7, the dividend will be 24 is equal to, and the divisor will be 4. So now we'll divide 4 and 24. It goes 6 times 24 here. After subtracting 4 minus 4 0, 2 minus 2 0. So here we have at the last find 0 as remainder. So here we will multiply by 6 and remainder is 0. So this divisor 4 will be our HCF. So here the final divisor, that is 4, will be HCF by the method of Euclid's algorithm. So friend, we have got 4 as HCF. So these are the steps to find the HCF by algorithm, Euclid's method. So friend, this all's for today. The rest part of this chapter will continue in the next video. And the one thing is, if still you have not subscribed the channel, please do subscribe the channel and do not forget to give thumbs up to the video. So see you in the next video. Now thank you for watching the video.